This time around, my friends, we're going to talk about graphing linear inequalities, and we're going to even throw an absolute value in here. When we graph linear inequality, inequality means we're not going to have an equal sign. We're going to either have a greater than sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign, or a not equal to sign, although for this lesson we're only going to be using the first four, not the not equal to. Alright, so let's start with the graph here, and let's just review. How would you graph this linear equation? Notice it has an equal sign in here, but this is just for review. And this is in slope-intercept form, so the slope is 2/3, the y-intercept is 1. We start by graphing the y-intercept by putting it at 0, 1. And then we're going to use, from that point, we're going to go up 2 and to the right 3 to get that point. And then we can connect those 2 points with a straight line. So that's our little review here. Now we're going to use that, but we're going to add some things to it. If your equation that you're faced with is not in slope-intercept form, first you have to put it into slope-intercept form in order to be able to do inequalities, because you have to have the y on one side and everything else on the other so you can tell whether it's greater than, less than, whatever. So our first possibility is y is greater than our mx plus b. We could have y is greater than or equal to mx plus b. Y is less than mx plus b, or y is greater than or equal to mx plus b. Now what does that mean? Well, for this first one, it means we're going to have a dotted line because it doesn't have an equal sign, so it can go up to that, well, the value can go up to that line, but it cannot touch that line. It cannot be a value on that line. So we'll have a dotted line, and because it's greater than, we're going to shade above. If we have greater than or equal to, that means that the value can go right to the line and actually lie on that line. So it's going to be a solid line and shade above again because it's greater than. Y is greater than. Y gets bigger. So it's a solid line and shade above. If we have a less than sign, what that means is, once again, it'll be a dotted line because it is not equal to. The dotted line with a linear equation is like the open dot if you're just graphing an inequality in one variable. So dotted line and shade below. And the last one is a solid line because it has equal to with it, and shade, this is shade below because it's less than. Greater means y is getting bigger. So if you look at wherever your graph is and you shade where y is getting bigger, look at the y portion of the graph and see where it's getting bigger. And less means y is getting smaller or less, so that's why you would shade below the line. Okay, steps to graphing inequalities. You might want to write these down so that you can remember it. And everything, if you follow these steps, you'll have a perfect solution each time. And this is in two variables, x and y. The first thing we want to do is get the equation into slope-intercept form. If it's in standard form or if it's in point-slope form, you want to put it in slope-intercept form. Your y has to be on the left-hand side of the equation so you know when you graph it which way you're going to shade. So you have to put it into y equals mx plus b form. Then identify the slope and the y-intercept. Pull that out and write it down. Then graph the y-intercept, and from there you're going to use the slope to find the second point. You're going to go up and to the right or down and to the left, depending upon what the slope is. And then you're going to draw your line, and your line that you're going to draw is going to be dotted if it doesn't have an equal with it, if it's just greater than or less than, and it's going to be solid if it's greater than, equal to, or less than or equal to. And then decide where you're going to shade. If it's above, that means that y is greater than, and if it's below, it's going to say y is less than. Okay, so let's get this first example going. So we have y equals 3/4 x minus 3. So here's our graph started. The slope is 3/4 and the y-intercept is -3. Step one is to identify your slope and your y-intercept. So now we're going to plot our y-intercept, which is -3, and then we're going to use that to count up 3 and to the right 4. which puts us right there. Now we're going to determine what kind of a line are we going to draw. Well, it's greater than, doesn't have an equal to, so that means it's going to be a dotted line that we're going to put through there. And then it's y is greater than, so we're going to shade above. Pretty simple, huh? Okay, let's try another one. Example 2. Y is less than or equal to 2x plus 3. There's our graph. So the slope is 2, and I'm going to put a 1 under it so we know which direction we're going, up 2 to the right 1. And our y-intercept is 3. So we always start with the y-intercept, and we're going to plot that 3 on the y-axis, and then we're going to do our slope, and our slope is go up 2 and over 1. We can also go down 2 and to the left 1, up 2 to the right or down 2 to the left. And the reason we can do that is 2 over 1 is the same as negative 2 over negative 1. So that means the negative 2 over negative 1 means we would go down 2 and then to the left 1. Now take a look at our little inequality sign. It has an equal with it, so we're going to draw a solid line, and it's less than, so we're going to shade below. See how y is getting smaller on that side. Okay, let's try one that's in standard form. So the first thing we're going to have to do is change our standard form to slope-intercept form, which means we solve for y. So I'm going to move the 3x to the other side, have 5y is greater than minus 3x plus 10. I divide everything by 5, and I have y is greater than negative 3/5 x plus 2. So that means my slope is negative 3 over 5, and my y-intercept is 2. And where do I start? I start with my y-intercept. So I'm going to plot 2 on the y-axis. Then I'm going to go down 3 and to the right 5. I can also go up 3 and to the left 5, and I'm still on the same line. And that helps if you've got a real small little graph that you're at the top of the graph and you're about to run out and you don't have enough grid left. You can always reverse it and go the other way to get your other point. So now I have, and I'm looking at that inequality sign, and it's greater than. So I'm going to have a dotted line, and I'm going to shade above. Okay, let's try an absolute value, just for kicks. I have y is greater than 2 times absolute x minus 1 plus 2. So there's my graph. And you remember, when we do absolute value, we only plot 3 points. And the first point we're going to plot is the vertex. And the vertex here is 1, 2. Remember, the number associated with the x is going to be the x term, and it goes backwards from where you would think. And then the number out to the right is the y. So I have 1, 2, that's my vertex. Now what I want to do is there's my vertex plotted. I want to find a number just below 1 and one just above 1, and I'm going to go the same distance below as above, and it just makes good sense to just make it 0 and 2. So now what am I going to do? I'm going to start by plugging in 0 for x. So I'll have 2 times the absolute value of 0 minus 1 plus 2. The absolute value of 0 minus 1 is minus 1. So I will have, and the absolute value of minus 1 is 1. So I have 2 times 1 plus 2, which is 4. So I have 0, 4 is another point on my absolute value. Now let's check out 2. And what we're hoping to do, if we haven't made any arithmetic mistakes, we'll get the same y value because of the symmetry that we have in absolute value. But let's try it just to check it out. So we have 2 times absolute 2 minus 1 plus 2, which is 2 times 1 plus 2, which is 4. So there we have 4. So we'll plot our 0, 4 and our 2, 4. Now I have to determine what kind of line I'm going to attach these with, and since it's greater than, it will be a dotted line, and since it's greater than, that means y is getting bigger. Where is y getting bigger? Well, it's getting bigger inside that v. So I hope that helped out for some of you who are a little confused, and we'll continue this in class. See you later, folks.